This is Get Out by Jacob and Min.
So literature review and resources. This YouTube video gave us the inspiration of individually coding for collision detection on each of the sides of the rectangle. Our mentors also helped us a lot, and the original UCSD Cosmos Pygame tutorials taught us many of the functions that we used throughout the project.
We wanted to create a more realistic collision system than the one we had used in the past, where the player could jump through platforms and get stuck in one. And we wanted to make it so that two players would have to work together to get to the end. We also implemented a gravity system that accelerates obstacles and moving platforms, and a leveling system where the maps become gradually harder to clear.
We spent a bulk of our time trying to perfect the collision system, and after trying multiple things, we found it best to code for collisions for all four sides of the players to get the best effect. We used tuples and a dictionary to accomplish this, and we received a lot of help from Eunice during this process. We created another player that used different keys to move around and created different maps and levels to add depth to our game.
These are some of our photos. On the left, we have our code that we use to make both of the players move using the arrow keys and then the WASD keys. On the top right, we have our code that we use to make loops for each of the levels. As you can see, we have a function called draw in our loop with a bunch of parameters, and this function is responsible for drawing most of the components of the map. In the picture on the bottom right is a picture of the first level of our game.
This is our demo link.
Challenges. The first challenge is that the glideless function caused faulty collisions, and the players would be able to jump through the platforms and sometimes got stuck in them. We solved this by individually coding for each of the four sides of the rectangle for more accurate collision detection, and took advantage of dictionaries and tuples to help us accomplish this challenge. Since we had so many elements in each level, level loops got very congested and hard to interpret at one point. So we created a function called draw that would draw all the components of the level, and then we would use this function in our game loop and simply pass in components as parameters to create each level.
There are a few improvements and features that we could see adding to the game in the future. One would be to create more moving platforms and objects so that the game has some more action to it. We can improve the animation of the player sprites so that instead of looking stationary while moving, the players have more realistic movement animations. We would also like to add a shooting element into the game so that the players can shoot at enemies in order to reach the end. And we could also implement this game onto the Raspberry Pi so that the players can use an actual game controller rather than a keyboard when playing.
This concludes our presentation. Thank you for listening.